Okay, so if we can be heard over the air conditioner, we're now in the workshop, and I found a bass mic because I couldn't find a normal one, and I've been a very clever person and found the correct system service manual. So what we have to now hope is we can find the correct page, and it's error codes. That's UHF. That's high band. That's low band. So if we get to the instructions, also known as destructions, UHF, So if the phase-out loop is out of lock, an audible warning will be heard and 03 will be seen on the display. Now then, of course, I'm bound to be on the wrong. Is this UHF? This is the trouble when you've got manuals which cover everything. I'll use that as a marker to see whether we can get any instructions here earlier on. Right, phase-out loop alignment procedure is common to the high band and low band modules. 03. So connect a voltmeter to test point 1 and select a frequency in the middle. Set TC3 and TC4 to half mid position. On low band, that's L800 and 801. So let's look at that board. L800, L801 to mid position. L800, 801. So we've kind of got a feel where they are unless we start taking the lid off. I tell you what, we'll take the lid off because it's a demonstration anyway, isn't it? However, you wouldn't normally take the lid off. So L800 801 changes glasses. That looks like it needs to go down. Wasn't far wrong there, was I? So for them to get it to lock on those higher frequencies, they really had stretched it, I think, to the maximum. Got a noisy volume control, so you know, again, I'm not here to do that. See what we have next to do. Basically, they want you to look at your list and note the voltages you've got between the channel limits. I just need to note where TC800 is. Yep. TC800 is transmit. TC801 is receive. So 800 transmit, 801 receive, and 801 of course was received there. So they're both numbered the same, which is kind of handy. Now these negative chassis, I think they are. Let's plug it down there. Test point 1 is there. So we're basically going from 70.3 to 70.5. So channel 1 to channel 17 is top of the shop. So 2.02 to 1.99. It's neither here nor there. So I think channel 13 will be fair. So that's 70.45. So I'd like that somewhere. Let's see where we're in lock and where we're not. So I think that's about the centre of where we want to be. So we'll have that at there. Right, we'll press transmit. Helps if I've plugged the mic in. So we've got error 3 now on transmit, and of course that's because it's out of lock on there. Okay, so we've now got the VCO locked. I've decided about 3.3 volts. That's our receive one, and our transmit one is 3.25. And I'll just quickly pop the power down to around about 10 watts. So we've got lock and we've got no error codes. So I'll just go to channel 1, and we've got transmit lock, we've got receive lock. I'll just go through to channel 17, which is the highest one. We've got transmit lock and we've got receive lock. So hopefully we're done. I'll put the lid back on, but we won't put all the screws in at this stage. And it appears to me as deaf as a post. And that's a plus 30 signal, which we're not hearing. Crank it up a bit more. Yeah, we can just about hear it at, what's that, 100 millivolts? Still transmitting. Let's look at what it's transmitting on. It should be 72475. We'll just pop that up a bit. I can never remember which is coarse and which is fine. That must be coarse. Well, I think that's about as close as we're going to get it. Let's go down to channel 1. Should have 70.3, 70.29999. And on channel 16 17, 70.5. Yeah. So he's pretty deaf. I can start by doing these by ear. Now these are right at the top of the scale. So what proof have I got that that this lid belongs to this set? Supposing it's a different version, he'll just end up with a deaf set, won't he? That volume control's annoying. Well, first of all, we'll go down these by ear. Then we'll plug the extension speaker in to the testing instruments. Ready? Right, let's see whether we can get it. Get all these down to a sensible position. That's S9. Doesn't sound too good. Let's put the sound admeter on. At least it's starting to become usable. That's 10 microvolts. Wow. 1 microvolt. got at the moment, we've got 0.75 microvolts. So let's just see if we can get that a bit better. I think that's the detector down there. So we'll put the oscilloscope on, turn the bench light off, turn the volume down a bit. Put S9 on. Now I'm not going to pursue trying to move that. It is receiving how we'd kind of expect. So what we got? Yeah, 0.75 for 12 decibel cyanide. So, seen better. I was just wondering whether it had the sensitivity, because these are mid-90s, times have changed a bit. See if there's a specification. High band. Reckons to be 0.35 microvolts. It looks like it's the right band, but isn't going to go any further. This might be a situation where you saw me with that Spectrum preamp. This might be a situation where this would work better with the preamp, but that is as spot on as it's going to go. It's about on a par where ours are, to be honest. And these days your background noise can be so high that you know, anything like good sensitivity is through the window anyway. So just to reiterate that the transmit power preset is a blue preset down there, and if I go into transmit, we'll just now get that to 10 watts. And 10, oh, I'm not showing you. So key up, there's our 10 watts, there's 5, normally I'm 4 for CB. So there we are, that is there. Now the deviation, I'll have to reset my machine. So it's 70. Wallow. Now that I can't remember which preset is which, that's CTCSS, so I think we need to go into one of the channels that is CTCSS. So his channel 18. So it's channel 18, press transmit, make sure we're wallow, and what we're looking at, can you? Oh, I can't show you both displays at once. Your CTCSS is supposed to be 70 Hz. So if I go over to the frequency display, it's 77 as it should be. If I go back to this meter, we want it to be about 0.37 for its deviation. So that's 2, that's 1. It's a little bit high. I've got to try and be quiet. Set it about there. Wallow. We'll get our little oscillator out. I'm sure that's deviation. But you know what? It isn't doing it. So we'll cancel that. We'll just go back to the service manual. It's RV4. You see, RV3 would be normal deviation, but we're not on the normal. We're not on the normal adjustment. So it's RV4. So let's go back to our layout. Yeah, that's RV3. That one would be CTCSS normally if you haven't got the systems board. That is deviation. I think that's digital code squelch. So we'll go back to that test again. Yes, it is. That's correct. Switch that off. I'm going to have to do this with a standard mic. Wallow. Now that's too high. Wallow. They are different, these mics, to a standard one, so just need to make sure what we're doing there. So I'm satisfied that I can screw this back together, and when I've screwed it back together, we'll just check that voltage once again. But it's somewhere around 2.8, 3.5-ish. We don't want it to be 0.9 and we don't want it to be 7. I'll switch it off and switch it back on again. So we've got 3.3 there. Press transmit. .2. That's fine. So apart from setting that with a standard microphone, which is something I'll do behind the scenes, that's it. Now, how far do I go with this? You know, the job is to program it for amateur radio use. You know, if this was a business radio, I'd be changing some of those capacitors, but it isn't. And he's not wanting to go and have a huge bill, I am sure. Because I found that most radio amateurs actually don't value things like that. They didn't pay 500 and something quid for it, so they don't value them. He probably paid 10 or 15 pounds. So he doesn't really want to spend much more than what we're charging for programming and servicing. So now we're doing something beyond the call of duty. I will just check Squelch performance, that would be sensible. We've actually got to take these out. I'll have to cut the power. We've actually got to take this board out to be able to clean them. And I've got to look at the time because I've got a church service. This is the kind of thing that can make the difference between being able to send a set back and actually keeping it another week, because you know it can overshot the time. It's different when it's a hobby, and I'm doing this on a Sunday just to kind of get this out of the way because it's not what we do. I've never had a pin driver. If any of you know where you buy pin drivers to do these things, then tell me. But at least you can get inside them once you've unscrewed it. When I was at Nottingham Radio, it was quicker. We'd just buy a complete front for 25 quid. You know, that would be what it was. Speaker, display, everything. I seem to recall it was a £25 standard part from Maxon, and you just plug it in. There's also a capacitor that can go down and cause these volume controls to be noisy. But I think this would be unusable if it was that. I borrowed the round nose pliers out of the organ workshop. We make often as 16 gauge wires we have to put an eye on, and that's why we have those. But in this case, it's just the job to tighten those back up. So one thing I do want to do before calling it a day on this, and without losing a screw inside it, is the squelch. So I'll just try and get some of these back in. When I've got the I'm going to do I did the Harvard 404 base station yesterday, and I think next Saturday I might do the Harvard 407. We've got 3 of those. Do you think I ought to sell it on eBay when I've done it? That would be funny, wouldn't it? I don't need 3. Yep, that's still working, and we'll just check this squelch out. So I'm going to turn the squelch to full. Oh, it needs to be stronger than that. But there's another RV1 just to confuse matters. So RV1, if we have it this way on, the other RV1 is there. Yep, that's the squelch. That's the other squelch. Okay, we'll go back to setting this. Right, that's full pelt, and it's 10 microvolts. So let's see what the sensitivity is now like at the bottom end. So I'll park this signal generator at 0.3 of a microvolt. We'll turn the squelch down to minimum and set threshold. Put the signal generator back on. And when does it come in? One and a half microvolts. We need more sensitivity than that, so we're going to have to do with less. It's not like CB where you've got S9 of racket, so we'll drop that down. That to full. We'll have it squelching out 10. We'll do that lower test again. So sensitivity, squelch to threshold, signal generator on, signal generator. That's it. That's where we want it. So it's coming in at 0.9 of a microvolt, dropping in off at 0.75. Now we said for 12 decibel cyanide it was doing 0. I'll just check what it was doing. Squelch has come in now. Yeah, 0.75. But let's see how far down we can hear it. So let's put the attenuator controls on here so we can see it. So 0.76543. Go on the other scale. So you can hear it down to about 0.2 microvolts. So it is, you know, it does have some useful sensitivity, but if it was mine, I'd want to be using it with the preamp to get my biggest bang for the buck. So that's see how that volume control. Well, I put them on the wrong way round. It's the smooth one for on and off. Oh, if I can get it back off again. Now, when this goes to a CTSS channel, it's going to go into total lock. So at the moment we can hear the signal, and if we move away from there, the radio is going to sit there hissing. But when I hit one of those CTSS channels, it's going to be full lock. So on channel 18 and 19, it's not going to say a word because it's got CTCSS. But to release CTCSS, I want to use it's the S button for monitor. Okay, it's the 1 button. On these sets, it's the 1 button for monitor. And then we can go back to full lock. Monitor, full lock. channel 19, monitor, full lock. You don't have to do that on the other channels because they're open channel. I don't know whether this scan's going to happen. I'll have to try it with a standard microphone. But there you go. So we'll do an on-the-air test later on with this, and hope you've enjoyed watching the Maxon PM150 be put on 4 meters with 19 channels. Thanks for watching.